All right, these are names for the first.
Over here. I'm Summer, am I?
Yeah.
I'm Emma.
All right. I just stopped it. It's okay. I don't want to waste the whole time putting in the whole thing. I just want you to put in the first three numbers. So 62.5% of you got it right. The rest of you got it wrong. What is that number? Maybe you typed it in wrong. What's the whole number? 6.02 times 10 to the 23rd molecules is the number of molecules in a mole. So if our concentration is based on the number of molecules, we don't want to go around saying 6.02 times 10 to the 23rd every time. So what do we say instead? What do we call it? It's one mole. Just like you don't go say, I want 12 eggs. You go to the store and you want a dozen. So our word is mole. So we're going to be looking at a concentration called molarity. The abbreviation for molarity, the unit of molarity, is capital M. Yeah,
Like
I'm going to put it on mine.
Like she got all over the L solution.
Right.
That's what I'm doing right now.
Chemists, hurry up, Josh. Chemists, as we've talked about before, are lazy. They don't want to have to write out mole of chemical per liter of solution. So in order to make it short and sweet and easy to write, they use a capital M. So the number of moles, how do we measure this? 6.02 times 10 to the 23rd molecules equals 1 mole. So molarity is the number of moles of the chemical divided by the liters of solution. That gives us molarity. So when you are looking at molarity, I want you to think, if you are looking for X molar, you're looking for the molarity, I want you to think moles per liter. And I want you to actually write it down so that you remember that's a fraction. Yeah.
On that paper, the definition of concentration is two separate things. So doesn't you write that down?
Just use what I have up here.
Is that an R?
No, it's just where I messed up. It's capital M is what I was trying to make. And my pen froze right here. We'll go. Yeah, put them on the table behind you. You may not need them. I just wanted to hear to see how they work. All right, so all the problems we're going to be working on this unit has at least two givens. You have two numbers, and you have to be able to decide which one to start with. So when you see a number that has a capital M by it, that's the concentration. The unit of capital M is moles per liter. So it is a fraction. Then you will be given things that are not a fraction, like 45 grams. Is 45 grams a fraction? No. Or you will have 56 milliliters. Would that be a fraction? So if you are looking for a fraction, then start with a fraction. So if I'm looking for molarity, that's a fraction. I take my two givens and I make them into a fraction. Okay? I'm going to demonstrate some of these examples in a minute. If you are looking for a non-fraction, then start with a non-fraction. All right. Three types of problems. All the problems have two givens. This first example, I'm looking for molarity. But you can read the problem and find out I'm looking for molarity. You see the two numbers?
Yes.
The two givens. So the first thing you need to determine, what am I looking for?
Molarity.
Molarity. Remember, write mole per liter. Why did I write mole per liter?
To know the fraction.
To make sure that I know I'm looking for a fraction. Okay? So the two givens should be arranged in the way that I can make in a fraction. So which one of those two givens can I get to moles? The grams, it's easy to change to moles. And you can't use 22.4 on these problems. So 22.4 liters is a no-no. These are not gases. These are liquids, like the ones that you dropped on the grid on the lab you did last week. So these are liquids. They're not gases, and you only use this when you have a gas. So don't use it. No, no, no. All right, so 75.3 grams NaCl is the chemical, and remember, I wrote it mole per liter like this, but it actually means moles of chemical per liter of solution. So I have a chemical given in this problem, and I have liters of solution given in this problem. So on the bottom, what do I need? Some volume, which is 3.50 liters. Do I have to do anything to the liter so it matches up with what I'm looking for? No. Do I have to do anything to the grams? Yeah. So we've changed from grams to moles for the last of September. GMM, somebody probably could tell you what it is without the nearest hundred. 58 point something. 45 grams of NaCl to 1 mole NaCl. Cancel. And my answer comes out in moles per liter.
That's right.
All right, use your expression and type in the correct numerical answer. Get your calculator. Let's have it out already. Don't make me look at it. Don't worry about the name. We're not going to reassign them because I'm not going to check to see that you got it right. Okay. So let's go up here and see what we need to do. I don't know what you need to do. Come here. Let's turn it off and turn it on again. Try that.
I tried that.
That was happening too.
Oh,
Mine ain't up.
Okay. I don't know what I'm saying. Well, we're still trying to figure out how to use them. So.
Mine not there. Mine
All right.
Taylor, Brad,
Okay. Sarah and Danielle are. All right, so do we agree that the answer is 0.368? 75% of us agree. Some of you, how many significant figures do we need?
3.
We need 3 significant figures. Some of you put 2 significant figures. Why do we need 3 significant figures?
The 0 is significant.
Zero follows out.
Right, that 0 is significant, isn't it? Following is a trailing 0 after a decimal, and I've got 4, ones never count, 3, 3, and 4. So our answer should have 3 significant figures. So those of you who rounded off to 3.7 shouldn't have rounded off, and those of you who had 0.36, hey, round off. If you're going to round off, at least do it correctly. I mean, you're gonna miss a point because you didn't round off properly. You're gonna miss a point because you don't have the right number of certificate figures. Come on, don't gift me points because you haven't figured out how to round off yet. This one is the same as this one. You just put the 0 in the front. So, what happened here? 0.362.
They might have pushed.
Wrong button.
Wrong button? Wrong button? Okay. All right. So, that's one type of problem. This type of problem, you are looking for molarity, which is a fraction, so you start with a fraction. So the first thing I wrote right here was a fraction. Then we go to the next type. Somebody who's a clock watcher, let me know about 10 minutes before we go to lunch because I've got something else planned. I need to know what that is.
Okay.
All right, if you are looking for mass or moles. Now, how many of you have used the molometer in the back of the room? A molometer.
Which one is that?
What is it?
Do we have one?
I don't think
No, we
so.
don't have one.
I don't
So
think
if I
so.
want you to, if I need to know moles, what do I have that you can measure? Grams. So if you need moles of something and you're supposed to mass that or get a certain number of moles, you don't go back there with a molometer because we don't have one. There ain't no such thing
Ain't
as a
no.
molometer. So you have to know grams because we do have a balance. And we use grams. So if you need moles, this question right here doesn't tell you what you're looking for. It asks you to describe how you would make. So you need to know two things in order to make a solution. You need to know how much of it and what volume of it. And you can't use a molometer, so you don't need moles, you need grams. So you see this type of problem all the time. And when it says describe, can you describe in a number? No, you need a sentence. So when the question says describe, your answer will be in sentence form. So let's talk about what we know. We know a volume and we know a molarity. So we're either looking for moles or grams because it's always volume, molarity, moles or grams. Well, I either need moles or grams. If I'm going to describe how to make it, I need grams. So I'm looking for grams. We all understand?
Yes.
So we're looking for grams. What are you going to start with?
Grams, milliliters.
Well, I'm going to start with milliliters and not molarity. It's a fraction. And grams is not a fraction, so I start with the not a fraction. Okay? Of the two given. So 450 milliliters. Now that molarity is moles per liter. What do I have to do to milliliters so I can
Change it
use
into
my
liters.
molarity?
Change it to liters. You got
Change it to liters.
1,000 milliliters.
Right, on cheat board. 1,000 milliliters, 1 liter. Now milliliters cancel. This is milliliters and liters of solution. Now I can use my molarity. The molarity. 0.65 moles of what chemical? NaOH. 1 liter solution. Liter solution cancels. I need not moles, but grams, so that would be 40.00 grams of NaOH. Where'd I get 40? Courtney?
Oh, add stuff up.
Courtney? Where'd I get 40?
Oh, add stuff up. Hold
Yeah,
on.
add stuff up, you're right.
I
Add
wrote
stuff.
it
You
the
said you
wrong
were
spot.
confused. I heard
No,
you.
I said I wrote it wrong.
Oh, okay, you said you were confused. All right, so 1 mole of NaOH cancels moles, gives me grams. Somebody needs to y'all need to calculate that for me and tell me the answer.
Can we do it on these little things?
Yeah, you can do it on little things.
I had 12.
I want my name to do
Well, Josh, we didn't take time to rename them, and you would have missed the renaming anyway because you went to the restroom late instead of early.
What is
So
that?
you would have missed the renaming. Name's not gonna be on it.
That's
What y'all say the answer was?
11.
No, that's a 1. That's 1 mole. What always goes under or over the DMN? 1.
I got 11.7.
All right, so we got 11.7. Why 12?
I thought you still need that 0 to make it 3.
Yeah,
Well,
but
that is 3, but how many is
I
that?
thought you coming from the 0.55 when you said 0.
That zero's in the front. It's not a trailing 0.
12.
So the answer is 12 grams NaOH. That's the numerical answer. Now the describe. Take 12 grams NaOH and add enough water to make 450 milliliters of solution.
Milliliters?
Milliliters of solution. So we would go to the back, we would measure out 12 grams of NaOH, we would put it in our container, which in this type of case is supposed to be a volumetric flask, and I don't have the volumetric flask up here. And then I would add enough water to make it 450 milliliters. I would not start with 450 milliliters and then add the solid to it because I would have a larger volume, because the solid is going to make the volume go up. Imagine taking a glass of water that's full to the rim and adding a cup of sugar to it. What's going to happen? It's going to overflow because the sugar takes up volume as well. So this chemical, this solid chemical, takes up volume. So we don't start with 450 milliliters. We start with the solid and add enough water to bring the total volume up to 450. Okay? We're going to be doing that in lab probably Wednesday. So it's important that you get this up here. We're going to actually do it in lab. You'll have to describe what you did as your lab report. It's not going to be a formal lab report. All right, so this is the second type. The first type, looking for molarity, we had a fraction, we started with a fraction. Second type, we're looking for grams because we're given volume and we're given molarity. So we not a fraction started with not a fraction. Now the next one, we have looking for the volume of a solution. This is also not a fraction, so we're going to start with not a fraction. What's units of volume that we know?
Liters.
We know what? Liters, milliliters, anything cubed, that's centimeter cubed, decimeter cubed, any unit of length cubed. Now, in your handout, on the first page, it says something about decimeter cubed. Well, one of the equalities for this handout you need is 1 decimeter cubed equals 1 liter, and it's on that front page, is equal to 1,000 milliliters, is equal to 1,000 centimeters, whoops, right, centimeters cubed. So, it takes 1,000 centimeters cubed to make 1 decimeter cubed, and 1,000 milliliters to make 1 liter. So here, instead of having 1,000, it says 1 centimeter cubed is equal to 1 milliliter. But that's the same thing as saying 1,000 milliliters is equal to 1,000 centimeters cubed. Divide both sides by 1,000. Okay? So you can use any of those conversions to convert from one unit to the other. Now, on this one, we're looking for milliliters of solution is equal to, we have two givens. This one is moles per liter.
Is that abbreviation for solution?
Yes. This is abbreviation for solution. SOLN. That's abbreviation. So which one of those is not a fraction? The one that has the capital M or the one with the G?
The one with the G.
Remember, every time you see the capital M, think fraction. All over liter. All right, so 50.0 grams CaCl2. What do I have to do to that before I can think about using molarity? Change it to moles. So I don't know what the GMM is. 71, about 71 plus 40 is 111 about grams of CaCl2, 1 mole CaCl2. Cancel.
Oh.
Courtney, you got a question?
She had that 110.
Yeah, I just rounded off. I was adding my name. So that's not the correct GMM that's showing. All right, now what do I need to do? I need to get rid of moles. How can I get rid of moles? All right, so that right there, when we look at it, 0.500 moles of chemical, which in this case is, I won't write moles of chemical, CaCl2 per 1,000 milliliters of solution. Now,
Okay,
wherever...
I got it. I was going to say, where did you get that from, but you changed it.
Right. If it confuses you, I can put 1 liter. We'll have to add an extra step.
But I got it.
All right. Now, here's the thing. Where do I put the moles? I've got to flip it. And when I flip it, what's got to be drug along, Courtney and I will, what's got to be drug along with that unit? What number? What number goes with the mole unit in this problem? All right, so if you go 55 miles per hour and you drive that speed, how far are you going to go in an hour?
Oh, no, we don't.
Well, if I'm driving 55 miles per hour, every hour I'm driving how far? 55 miles. So what number goes with the mile? 55. Okay? What I'm trying to get you to see is that that's an understood one right there. Okay? And that unit goes wherever the miles goes. It's superglued to the butt of the miles. We talked about this before. So what's superglued to the mole? So what? The 0.5. So wherever I put the mole, that's where the 0.5 has to go. So when I flip it, I got to flip the number too, not just the unit. But you knew that. You just didn't understand my question. More than likely. Okay? Yeah, but you didn't understand what I was asking first. Because everybody, I think, knows by now that if you flip the factor, the numbers have to go with it. They don't stay where they are. All right, so I'm going to put 0.500 moles of CaCl2 and 1 liter on the top. But that means, am I through with my question?
No, you have to change that liter to
What am I looking for?
milliliters.
Milliliters, and what do I have?
Liters.
Liters. So I have to add that extra step that I was trying to skip a minute ago. 1,000 milliliters. And if you stretch that out. If you understood what I was doing a while ago, you can bypass that last one by adding 1,000, putting 1,000 milliliters in the place of the liter. So it's the same thing. It's an equality. All right?
Okay.
What's the what? We're not registering them. So, and I don't know what the code would be if we did. Okay. This is some kind of question, but I don't know what that is. All right, so the type of problems you're working for homework are those 3 types. Now I'm going to put this online. If